just wait for 2 to 3 minutes.
Yes,
Those
sir.
students will join in. And Alan, will you be available on Friday? In order to cover the syllabus, we need to have some extra classes. So same time.
Yes, sir. For me, it's fine.
With
But
you,
then,
it's fine.
yeah.
Okay, so on Friday, the timing will be same. I want to take an extra class. Just wait till 6:40, then I will. That means 5 minutes.
Yes, sir.
Okay, thank you. Just let me check. Hamad, are you there?
Yes, sir.
So in the previous class, we had completed. We completed the carboxylic acid, aldehyde ketones, and carboxylic acid. Today we are going to start a new chapter, that is your coordination compound. Can everyone see the screen?
Yes.
So let's start with this coordination compound. It's a very easy chapter, and we will start from very basic coordination compound. So see, we are going to first learn what is this coordination compound. So I'm going to write the definition. Please do write it. So basically, compounds formed due to combination of two or more salt. Or we can write two or more stable salt. Two or more stable salt, which retain their identity. In solid state. Oh, wait a minute. Which retain their identity even in solution. Or we can say, or dissolved state. Are called complex compound. We can either say complex compound or coordination compound. So It's very easy to understand. When two or more stable salt forms, that compound is basically known as addition compound, and this addition compound is divided into two parts. Addition compound divided into two parts. The first one is double salt and the another one is complex compound or coordination compound. What is this double salt? So basically when two or more stable salt combine and they do not retain their identity in dissolved state as compared to solid state, that is called double salt. And the addition compound, which is formed by two or more stable salt, they retain their identity in solid as well as dissolved state. That is called coordination compound. Is that clear? I will show you with the help of an example. So first I'm going to write it. As you can see, addition compound. You need to write more in this chapter. Addition compound is basically of two types. Anushka, are you there?
Yes, sir.
Okay. Please do let me know anyone of you who don't understand. Addition compound is basically of two types. This is your double salt and another one is coordination compound or complex compound. Coordination compound. So please do write up to this and then we are going to do the rest further. Let me know when you are done with this.
Sir, done.
Done, everyone? Now see,
Just
let's
a
take
minute.
an oh, wait a minute, sorry.
Only such that addition compounds are to do just 1 minute.
Okay. Now you
Okay,
can
done.
see that. Thank you. Double salt. Let's take an example with the help of a sentence. That is, those double salt are those which lose their identity in solution. In solution. I will take an example. Let's take an example of this more salt. More salt. More salt has a formula. You can write the formula as NH4 whole twice FeSO4 whole twice dot 6H2. This is the form of more salt in solid state. But when you are going to dip it in solution or water, what will be the resultant? You can see this will be totally ionized and it will lose its character. It will lose its property. That means Fe plus 2 and then 2SO4 minus 2 and then you can write 6H2. So basically by decomposing or dissociating into ion state. Wait a minute, please. by decomposing or dissociating into ions, it lost its identity. This type of this type of addition compound is known as double salt. Is that clear?
Sir,
Sir,
can
can
you
you just
explain
repeat that again?
Uh, what I was saying is that double salt is the one, or double salt is that type of addition compound which lose their identity in solution. This is the double salt formula, which is more salt. This has different properties as compared to its ionic form. They are totally dissociated into ions and they will show their own properties and character. SO4 minus 2 Fe plus 2 and then NH4 positive. Are you getting my point?
Yes, sir.
Like NaCl is salt, right? It is solid, but when you are going to dip this in water, it will form Na plus plus Cl minus, right? So these two will have different properties than this. So basically, an addition compound which lose their identity in solution, that is known as double salt. Whereas when we are going to talk about this coordination compound which does not lose their identity in solution, solid state as well as in solution, it will not lose its identity. For example, you can take K2FeCl, K2FeCl whole 4 Cl2, and this is your square bracket. At the end, it is Cl2. So basically, when you are going to dip it in water, only the elements or the species or the groups which is outside the bracket will be ionized, but inside bracket it will be as it is. Inside bracket it will be as it is. Initially it is neutral. Initially you can see it is a neutral, and finally there will be no charge. So you can see that no charge, that means there is neutral. If positive, two positive comes out in the solution, so there will be -2 charge. If they again combine together, the charge will be 0. That's why there is a negative charge. So basically what I want to say is that this coordination compound has characteristic property of this bracket, a square bracket. In a square bracket, it will not dissociate, and that's why it doesn't lose its identity in solution also. Okay.
Yes, sir.
Yes, sir.
Please do write it and then let me. Shabnam Rahman, is this your first class? Shabnam.
Sir, can you just explain what was the example, sir, which you gave for K2 FECN, and then what is it?
I'm going to write it here. It's K2
Okay.
FECN whole 4 Cl2. This is the example.
Okay.
And it's whenever a compound that is written in a square bracket generally is a complex compound or coordination compound. Is that clear?
Yes, sir.
No. Please do let me know, Mehraj. Please do let me know when you are done with this. Anushka, are you done with this?
Yes, sir. Almost done.
Okay. Alan, Ahmad, and
Yes, sir.
Mehraj. Very good.
Almost done, sir. Just 2 minutes.
Mehraj, you are not responding at all.
Sir, no, sir, I'm understanding, sir.
Okay, okay. So I'll just slide it up and give a quick view. Okay, Mehraj. So just write it and I'll explain again. for you only.
No, okay. So, no, sir, I understood, sir.
Okay, that's good. Then write it and let me know when you are done with this. Thank you.
Done, sir.
Very good. Anushka and Mehraj, please do let me know.
Sir, done.
Yes, sir. Done.
Very good. Now we are going to learn some basic terms from this chapter, which is very important. So I'm first going to explain, then I'll write the definition and all, and you will definitely get it. Let's say this is your coordination compound. So see, if there is something here and here, these both are called counter ion, whether it is just before the bracket or outside, just outside the bracket, that is counter ion. If it is before bracket, that means it will be positive counter ion, always positive. Wait a minute. It will be positive counter ion. It will be positive counter ion. If it is outside the bracket, just outside the bracket on the right hand side, it will be negative counter ion. Are you getting my point? It's very easy. Outside the bracket, if anything which present outside the bracket, just outside the bracket, that is counter ion. If it is present just before the bracket on the left hand side, it will be positive counter ion. And if it is present just outside the bracket on the right hand side, it will be negative counter ion. As you can see, this the example that I had taken in this K2, what it becomes positive. So what I am telling you, this is the square bracket, and just before the square bracket on the left hand side, this is positive counter ion. If something is present on the right hand side of the outside bracket, that will be negative counter ion. Is that clear to everyone? I will define each one of these. Now see, if just
So can I just repeat that
Yeah.
before what were you saying? It was just lagging for me. That's right.
see, if anything present here or here, outside the bracket, left or right, that is counter ion. Are you getting my point? And if it is on the left hand side, so to be specific, that is positive counter ion. And if it is on the right hand side, that means it is negative counter ion. Got it?
Yes.
Now, just before, you can see on the left square bracket, if there is something, anything that is basically known as central metal atom, central metal atom or ion. If anything just present here, that is central metal atom. As you can see, if I have taken this example previously, so you can see this is your counter ion, which is positive counter ion. This is your central metal atom. And after this, whatever is present is basically is your ligands. Are you getting my point?
Yes, sir.
Yes.
So it's very easy. Counter ion outside the bracket. And just before this left hand side is square bracket, this is your central metal atom. And after this central metal atom, whatever is present inside the bracket, that is called ligand. We will see what is ligand. Basically, these ligands make a coordinate bond with central metal atom. We will see what is this. Just focus on the term. And again, there is another term that is used, that is basically your what we call, together this central metal atom and the ligand are known as coordination entity. Together they are known as coordination entity. Is that clear? Central metal atom and ligand. So again, I am going to repeat it. Outside the bracket, counter ion. If it is present on the left hand side, positive counter ion. On the right hand side, negative counter ion. Just before left bracket, just after the left bracket, central metal atom. And except of central metal atom, all are ligands till this bracket. Okay, and together this central metal atom and ligands are known as coordination entity. Is that clear to everyone? I think it's clear.
Yes, sir.
Now I'm just mark
Sir?
it and then yeah.
Sir, can you just explain once again what is a ligand?
Ligand is basically just take this example. Take this is central metal atom, Fe. Yes or no, Anushka? Generally, D block
Yes,
element
sir.
forms complex one. After this, Cn and Cl is basically your ligand. Okay,
Yes, sir.
and together this Fe, Cn, and Cl is your coordination entity.
Yes, sir.
Everyone, okay. Maraj and Imad, Alan, please do write it and just make a short notes of this. Then I'm going to define it. Right, you will write with me and you will get it. Very easy it is. So on Monday uh, just before the class, on every Monday you have you give test, right?
Yes, sir.
So, on coming Monday, since yeah, one more important announcement is that on Friday there will be an extra class on same time, like IST 6:30 p.m. I think at your place it's 4 p.m. right?
Yes, sir.
Okay. All I want to say is that IST 6:30 p.m. to 8 p.m. there will be an extra class on Friday. Please attend that class. Yeah, because we have a lot of syllabus left. So in order to cover the syllabus, we will be in need of some extra classes. So might be in this.
Sir, I can try, sir. I'm not sure if I can join us. This Friday, I cannot join, I think.
Why? Is there,
Because, no, sir,
yeah.
school is organizing a foundation day, so all the 12th standard boys have
Okay.
been invited today. That's why.
Okay, no problem. You can take extra class some other time, but I'll say,
If it's
Anushka, can you
compulsory,
join
sir,
it?
we'll see. But
No,
tomorrow,
if
let
your
them.
foundation day is there, so you may go there, and after that we can have an extra class on weekend or any other time. Anushka,
Yes.
Mehraj, and Alan, you were agree with this. Anushka, will you be able to join?
Sir, I will see, sir, because I guess in our school also we'll be having a mock 2 and preparation for the practical exams. So I think I'll be able to. I'm not sure.
Mehraj?
So I'll join.
Okay, thank you. Please do let me know when you are done with this.
Did this, sir. This one.
Very good. Anushka and Mehraj, please do let me know.
Yes, sir, done.
Alan?
Yes, sir, I'm done
Sir,
as
for
well.
this Friday's class, what will be the duration? 1.5 hours, same 2 hours?
Yeah, one and a half.
Okay.
Mehraj, are you done with this?
Yes, sir.
Thank you. Now, see, let's just start this some basic terms that I'm just going to write with some basic terms. So the first I'm going to take is central metal atom. Sometimes it will be known as central metal ion. Central metal atom. All right. So here you can see the coordination entity to which the fixed number, the ligands are fixed basically, the fixed number of ions or groups attached in a definite geometric in a definite geometry is called central metal atom. You will get it all, just write with me. There is another point which is very important. It is Lewis acid. We will discuss about it later, just after writing all the definition. Now I'm going to write coordination entity. It constitutes central metal atom or ion bonded to a group. Wait a minute. It constitutes central metal atom or ion bonded to a fixed number of ions or molecules with coordinate bond. This is with coordinate. So please do write up to this and let me know. First, I will write all the definition. Then I will explain. It's very easy. Do let me know when you are done with the first definition. I think you are done with the first definition, right?
Yes, the first definition is done.
Yes, sir.
Thank you. Now we are going to talk about this ligand. Molecules, ions with a pair of electrons to the central metal atom. To the central metal atom or ion is called ligand. And hence ligands are Lewis place. Please do write up to this. I think you're done with the first one completely. The next is coordination number. Everyone done with this?
Yes, sir, almost. I'm on the fourth definition.
Okay, thank you. Please do let me know when you are done with this.
Yes, sir, done.
Alan, Mehraj, Alan, are you done with this?
Yes, sir.
Okay, I'm going to ask you a question from Alan. What is acid, or to be more specific, what is Lewis acid? You have studied this in class 11, ionic equilibrium. Can you
Donors.
electron donors? Electron donors, did you say?
Yeah.
Okay. What do you think, Ahmad? What is Lewis acid? So see, you just did
Empty orbitals that are able to accept electron pairs.
electron acceptors are called lone pair acceptors are called Lewis acid. Electron acceptor is Lewis acid, and what is base? Electron donor. Base Lewis base. If you are going to define Lewis base, that is electron donor. Is that clear, Alan? That's why in organic chemistry, when we were doing acidic strength, acidity directly proportional to minus I, electron withdrawing group. So the group which withdraw electrons more are more acidic in organic chemistry. Got it, Alan?
Yes, sir.
So see, this is central atom, and central atom generally this compound is formed by D block element. There are some P block element which also forms this, but not all the P block elements. Majority comes from the D block element. Let's see, this is your K4, Fe, Cn, whole 6. So I'm going to define this is your counter ion, this is your central metal atom, and this is your ligand. And this ligand, and between this central metal atom, there is a bond that is known as, that bond is coordinate bond. So everyone knows about coordinate bond. Anushka, do you know what is coordinate bond?
So not really sure of them.
Okay. So see, this is also covalent bond. Covalent bond is sharing of electron, equal sharing of electron. This is a special type of covalent bond where unequal sharing of electron takes place. Unequal sharing. If I'm going to define this coordinate bond, what is this? So basically there is NH3. I'm going to take an example of this ammonia. There is NH3 on which nitrogen has a lone pair, and there is a H plus, which is electron deficient. H plus, that means it doesn't have any electron deficient. So what will NH3 do? It will donate one of its electron. So I'm going to write NH3 like this. Now you can see that when nitrogen donated its electron, only one of its electron, it will have positive charge and one electron will be with it. And since hydrogen gained one electron from nitrogen, it will have negative charge, but already it has positive charge. So positive, negative cancel, and it has now one electron. Now this electron will be shared between nitrogen and hydrogen, and this bond is known as basically your coordinate bond. Is that clear? Anushka?
Exactly.
And it is denoted by like this, that this arrow shows that nitrogen donated one electron to hydrogen and then make a bond. This is called basically coordinate bond. Now see, in this coordination compound in our syllabus, it is given that the bond between central metal atom and ligand is your what we call coordinate bond. That means Fe has 6 CN surrounded, which is bonding with Fe like this. So as you can see, the arrow, that means Cn has donated one of its electron to iron and then made bond or formed bond with this. And you can see since Fe taking electron, so it is electron acceptor. That's why this central metal atom is acting as, wait a minute. See the screen.
Yes, sir.
So that's why since central atom taking electron, so this central metal atom acting as Lewis acid. And since this, what we call this ligand is donating its electron donor. So that's why ligand act as Lewis base. Is that clear to everyone?
Sir, I'll just repeat that again.
See, Cn is donating a form bond like this. That means Cn donated one of its electron to iron, and then one Cn made a bond, formed bond between like this. Are you getting my point?
Yes, sir.
Like this, you can see NH3, nitrogen has donated one electron to hydrogen, and in this way we represent it. That shows that nitrogen donated one electron to hydrogen. In this, nitrogen acts as base and hydrogen as acid, because hydrogen is electron acceptor and nitrogen is electron donor. Electron donor is Lewis base, electron acceptor is Lewis acid. Now again you can see
Yes.
iron is accepting electron. That's why this metal, central metal atom act as Lewis acid, and Cn, which is cyanide ion, is basically donating its electron to form a coordinate bond with iron or central metal atom. Since it is donating electron, that's why ligand act as Lewis base. Is that clear?
Yes, sir.
Now come to the, please do write it if you want to write it in your own language or in your own way, so that you will be able to understand when you see the notes. I have written it in my own way. Please do let me know when you are done with this.
Done.
Everyone done with this?
Yes, sir.
Very good. Now see, what is this coordination number? Coordination number is basically the total number of bonds between central metal atom and ligand. As you can see in this compound, total number of bond is 1, 2, 3, 4, 5, 6. So for this complex compound, coordination number equals to 6. Is that clear? So what I had written here for coordination number, you can look. It is defined as number of coordinate bonds formed between central metal atom or central metal atom or ion by the ligand. So total number of coordinate bonds formed between central metal atom and ion, that is called basically coordination number. Is that clear to everyone?
Sir, can you explain this again?
See, if you want to see for coordination number, I'm just taking an example. Can you tell me total number of bonds between carbon and all hydrogen?
Sir, 4.
How many bonds?
4.
What you just said, I couldn't get you.
Sir, 4.
4. So this is 4. So in this case, the coordination number will be 4. In the same way, you can see Fe is surrounded by 6 Cn and it is making 1 Cn is forming only one bond. So 6 Cn will be formed 6 coordinate bond. That's why for this compound, coordination number will be equal to 6. Is that clear?
Yes, sir, understood.
Very good. Now see, it's very important to note that some ligands form more than one coordinate bond. Are you getting my point? So that ligand should be in your mind whenever you look at the ligands, you should know whether it forms a 1 coordinate bond, 2 coordinate bond, 3 coordinate bond, 4 coordinate bond. I will make a list and I will give you from your syllabus and you will get it. Got it?
Yes,
no
sir.
problem.
Okay, can I change the slide? Alan?
Yes, sir.
Okay. So for now, you need to remember that this CN is basically forms only one coordinate point. That means basically with question you will have to practice. See, one CN can make only one coordinate. Is that clear, everyone? Can I change the slide?
Yes, sir.
Okay. So if I'm going to ask you, can you tell me what is the coordination number for this? What is the coordination number for this compound? First one you can tell me. Please do let me know.
So is first one 2?
Yeah, it will be 2. Very good. Now see, I have written this. CN is on one CN will make only one coordinate bond. So 2 CN will make 2 coordinate bond. That's why the coordination number here will be 2. 1 NH3 make only one bond. One NH3 makes only one coordinate bond. That's why 4 NH3 will make 4 coordinate bond. That's why coordination number 4. 1 H2O can make only one coordinate bond. So 6 H2O can make only 6 coordinate bond. That's why coordination number is 6. Is that clear?
Yes, sir. Clear.
I'm going to take an example of bidentate. That means basically we will see how we'll define this term. Right now you have to just take it in your mind. This En is basically ethane 1,2 diamine. Ethane 1,2 diamine. Can anyone write the structure of this? You have studied this ethane 1,2 diamine in class 11th. Please do let me know. See, ethane, that means 2 carbons, CH2, CH2. And diamine, that means NH2 will be here and NH2 will be here. Since 2 nitrogen is there, that means 2 lone pair will be there, and it can donate from 2 sides. So 1 En can make 2 coordinate bond. So how many coordinate bond will be formed by 3 En? MR. If 1 En can make 2 coordinate bond, how many coordinate bond formed by 2 En?
So
Anushka?
6.
6. That's why its coordination number will be 6. When we will classify this right now, after this we will classify this ligands, then you will come to know how many types of ligands are there. Okay, is that clear?
Yes, sir.
Now see, this is the 4th one. I'm going to take the last example. FeC2O4 whole thrice as power -2, and this is basically your oxalate ion. and its structure is something like this: C double bond O, and then again C double bond O, and O minus and O minus. It can donate from one C2O4 can donate two. That means it can make or form two coordinate bond, one C2O4 or one oxalate ion can form two coordinate bond. So three oxalate ion can form six coordinate bond. That's why for this coordination number will be 6. If you are not getting it, just uh, don't be impatient. When I will write the classification of ligand, you need to remember it. Like NH3 is unidentate. That means it can form only one ligand. This is basically also unidentate. This is bidentate or didentate. This is bidentate or didentate. There are some ligands which are tridentate. There are some ligands which are hexadentate. That means only one ligand can form 6 coordinate bonds. So please do write it. And after this, we are going to do coordination polyhedron, and then two types of complexes, and then classification of ligand we will come. Please do let me know when you are done with this. Emma, Dhanushka, Alan, are you done with this?
Yes, sir.
Yes, sir.
Very good. So I think, do you have any doubt in this? Please do let me know, honestly. If you recognize whether it is making one coordinate bond, you can easily calculate the coordination number. So that type of ligand you have to remember. That I'll
Sir?
give a list. Yes.
Sir, how do we know if a compound is a bidentate or monodentate?
No, not the compound, ligand. Ligand. That I will give a list for this when we are going to classify it after 15 minutes. Okay.
Yes, sir.
Okay. Now, see, this complex compound or coordination compound are of two types. The first one is basically your homolaptic complex. We say homolaptic complexes, or homolaptic, you can say homolaptic coordination compound. So what is homolaptic? The complex or the coordination compound which is surrounded by single type of ligand, that is homolaptic complex. So I'm going to write with me. It's very easy. Complexes which have only one type of ligand are called homolaptic complexes. Are called homolaptic complexes. As for example, you can see I'm going to take a very easy example of homolaptic complexes. FeCN whole 6. So now you can see uh, now you can see this is your central atom which is surrounded by only one type of ligand. This is called homolaptic complexes. You can also write CuNH3 whole 4 raised to the power plus 2. So you can see copper is your central atom which is surrounded by only one type of ligand, that is called homolaptic complexes. I think it's clear to all of you. Ahmad?
Yes, sir.
Okay, thank you. Now heterolaptic complexes, now you know the drill. If homolaptic is surrounded by central atom surrounded by single type of or one type of ligand, what is heterolaptic? Which is surrounded by more than one type of ligand. So we can write complexes which have more than one type of ligand. One type of ligand are called heterolaptic complex. Is that clear? For example, we can take example of this CuNH3 whole 4 and then CO. Or you can take an example of K2 Fe CN whole 4 Cl. K4, make it K4. Got it? You can see more than one type of ligand surrounded by more than one type of ligand, that is heterolaptic complexes. This is your example. Everyone done with this? Please do let me
Yes,
know.
sir.
Yes, sir.
Yes, sir.
Now we are going to classify this ligand. So see, classification of ligands. To see what is it, first we are going to do on the basis of Charge. On the basis of charge, that means which type of charge exists on the ligand. So it is of three types. The first one is cationic ligand, that means the ligand which have positive charge. Then comes the neutral ligand, the ligands which have no charge. And then comes the anionic ligand, that means the ligands which have negative charge. Is that clear?
Yes, sir.
Yes.
So I'm going to write some examples, some of the example. These are the most basically this is the very less used cationic ligand in your syllabus. Neutral ligand, we have a lot of neutral ligand like H2O, NH3. This EN, ethane 1,2 diamine, is also a neutral ligand, except anionic ligand. We have a lot of anionic ligand like SO4 minus 2, Cl minus, Br minus, I minus, and we can also write Cn minus is a new anionic ligand, and also C2O4 minus 2. These are all your anionic ligand. And you can also write EDTA4 minus. We will discuss it what it is. It is basically ethane diethyl tetraacetate. Ethylene diamine tetraacetate, not ethane diamine. So first we discussed it or classified it on the basis of charge that you already know. Charges are of basically we can say two types, negative, positive, and the one which has no charge is neutral. So ligands are divided on the basis of charges: cationic ligand, NO plus, NH2 plus, etc. Neutral ligand, that is most used, and also anionic ligand is also most used in this chapter. So please do write it and let me know. Please do let me know when you are done with this.
Yes, sir. Done.
Very good. Alan, Ahmad.
Yes, sir.
Yes.
Sir,
Yes.
sir, did you correct the papers, the mock papers?
Actually, I was busy in my brother's marriage ceremony. I'll
Oh,
be sending the marks today. But only I think one or two.
yes.
You will get to know soon by tomorrow. Now
Okay,
see,
sir.
we are going to think. Now see, on the basis of denticity. On the basis of denticity. So first of all, I'm going to define what is this denticity means. So basically, denticity is the number of coordinate bonds formed by one ligand. So basically, what is denticity? A ligand which can form how many coordinate bonds, that is called denticity. So on the basis of this, we have the first one, that is monodentate. Monodentate, or you can say also unidentate. That means a ligand which can form only one coordinate bond. This type of ligand is basically known as unidentate or monodentate. So I'm going to write ligands having single donor atom, that is called monodentate. And I'm going to write the example Cl minus. Wait a minute. Let me know when you are able to see the screen.
Yes, sir.
Like Cl minus, Br minus, NH3, etc. are unidentate or monodentate. Whenever you see this, that means basically one of this can only one sigma, one coordinate. Now the next is basically we can write bidentate or didentate. Please do write it up to this. Then I'm going to define it and give some example. And it's very important to note that what is the charge on ligands, whether it is neutral, if it is negative, how much negative charge is there, or if it is positive, what is the positive charge on the ligand. Because in order to calculate the oxidation state of the central atom, we need to know the charges. Please do let me know when you are done with this.
Yes.
Done, everyone? Anushka?
Yes, sir.
Okay. So now we are going to do going for bidentate. That means ligands having two donor atoms. Two donor atoms. That means in a single ligand, we have two donor atoms that can form two coordinate bond alone. So in this, I'm going to take this En. En is basically ethane 1,2 diamine. Its IUPAC name is ethane 1,2 diamine, and it is denoted in this chapter with En. And you know that this will have lone pair, this will have lone pair, so it can donate and make a coordinate bond with this side as well as this side. That's why it is didentate. Also, I'm going to take an example like the earlier C2O4 minus 2, and this is O minus, and this is also O minus. So you can see it can make coordinate bond from here and here. And this is your C2O4 minus 2. It is denoted also with OX. Okay. It is basically oxalate. So you need to also take care of these charges while calculating the oxidation state. We will do some practice. So please do write it. And do let me know when you are done. Are you done with this?
Yes.
Yes, sir.
Very good. Now see, we are going to do for polydentate now. Polydentate. That means basically more than two or more than one, you can say. Polydentate ligand. Poly, that means many. It can form many coordinate bonds. So here you can see, I'm going to take the example of what we say. If you remember EDTA, so it is CH2 and there is N, which has a lone pair, and there is CH2 and there is C double O minus, and also there is CH2 and then again C double O minus. Then again we have CH2 and this is N, and again this is CH2 and again this is CH2, and this is C double O minus as well as this is C double O minus. Now you can see it can form coordinate bond from here, 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 here. 4 coordinate bond can form from here and 2 coordinate bond from here. So basically this is its name is ethylene diamine tetraacetate. Tetraacetate ion, which is denoted with EDTA 4 minus. Since you can see minus 4, you can see on each oxygen there is 4 negative charge, so it is denoted with this, and its coordination number alone is 6 because it forms 6 coordinate bond single EDTA 4 minus can form 6 bond. That's right, it will have 6 coordinate bond coordination number. Please do let me know when you are done with this. Let me know when you are done with this.
Sir, done.
Everyone done with this?
Yes, sir.
Now, we have a special kind of ligand that is ambident. Ambidentate ligand. You know what type of ligand is this? it has two donor atoms or two donor site, but it can use only one of its donor atom or site. So I can write a definition here: ligands which have or which can bind through two different atoms, but it will use only one at a time to form coordinate bond, to form coordinate compounds or coordinate bonds. This type of bond is known as this type of ligand is known as ambident nucleophile. Sorry, ambident ligands. Now this is your NO2 minus, SCN minus. This is the example of this. I'm going to show you how it can have two donor sites. Now, as you know that I'm going to talk about this NO2 minus. Now, NO2 minus has a structure like this, as you can see. O negative, O will have negative charge. Whenever a compound which contains oxygen and negative charge, the negative charge will go to oxygen, and there is like this. And since nitrogen is forming only 3 bonds, so it will have lone pair, so it can donate either from this side or negative charge from this side. So if it will donate from this side, it can do this O negative, and it can also donate from this side. So as you can see, it has two donor sites on different atoms, nitrogen and oxygen, but it can use only one at a time. Now for SCN minus, I am showing you SCN minus, that is basically negative charge here, that represent is on central on this. No, wait a minute. So it can donate from here, or either it can donate from nitrogen has lone pair, it can donate from nitrogen side or sulfur side, but it can only use one at a time. So this type of ligand is known as ambidentate ligand. I am going to repeat it again. It has two donor sites, but it can use only one of it. That's why it is known as ambidentate ligand. Is that clear to everyone?
Yes, sir.
Yes, sir.
So my request to all of you is that please do write it first and so do revise. I'll see you in the next. So also everyone done with this?
Almost there.
Oh.
Done.
Yeah, very good. Now see, you can see that we are going to, you are going to give a revision to this as well as read your NCERT about Warner's theory and do some questions I'm going to write here the topic, Werner's theory, and also